Welcome to Automated Visual Software Analytics. This part is about mining software repositories. We will outline different types of software repositories, explain mining of software repositories, and we will discuss mining objectives. Let's start with the question, what is a software repository? It has a very general definition. A software repository represents a record-keeping database that stores data about artifacts of a complex computer-based system. It tracks changes applied to the artifacts and stores corresponding metadata. So, the rule of a software repository is twofold. It stores the data, for example source code in a revision control system, and metadata about individual changes applied to that data. There are different types of software repositories, and one type most of you are familiar with is a history recording software repository. For example, version control systems or bug detect faults repositories or tracking systems. Even communication archives such as email or wikis belong to this category of software repository. In the example here, there's just a screenshot of some Git commands as a version control system. It's initialized, configured, elements are added, and changes are committed. Yeah, these are the most common form of history recording software repositories, the version control system. There are different version control systems, of course. Another type is related to system dynamics, to runtime data that is stored in software repositories. For example, deployment logs, trace data about execution of the system and the behavior recording, or any other type of application deployment data. For example, a typical bug tracker belongs to this category. Bugs are recorded, maybe associated with some trace data or at least error logs. This kind of software repository is always complementary to the history recording software repositories. The third type corresponds to large collections of software projects. So it's a kind of project software repository or simply code software repositories, such as SourceForge or Google Code or GitHub. They collect a large number of different and independently developed software projects. Mining software repositories constitutes a new field in software engineering. It aims at examining and analyzing the rich data available in software repositories to uncover interesting and actionable information about software systems and projects. Yeah, and mining software repositories also focuses on uncovering pertinent information, relationships and trends about a particular evolutionary characteristic of a system. Because software repositories store all the data that a complex software system requires and metadata that gives us indications about evolution, about processes, about activities, we have a really rich data store there, but we have to use it. And mining aims at taking advantage of the data stored in software repositories, in different kinds of software repositories even. Yeah, the rule of software repositories, it's an important rule for all activities related to software engineering. For example, software repositories contain a wealth of valuable information about software projects. They are actually first-class source of information because they precisely and completely store all relevant information about a software development project. Software engineering becomes a more and more data-driven discipline. That means we lower the dependency on individual intuition and experience of developers. this has to be compensated by a data-based, a data-driven information that can be taken from software repositories. Especially software analytics emerges as a key discipline that takes advantage of and applies mining techniques on software repositories. So mining software repositories is a key element in software analytics. Yeah, to understand the general workflow, let's look at this diagram. It outlines the general data flow in software analytics. In visual software analytics, we do have different software system artifacts. And typically, these artifacts are stored in different kinds of repositories. So here we have the repositories, the world of repositories. And now a key task for software analytics is to put that data into a consistent database that stores software analytics and software analysis data. This is done by so-called extractors. They crawl through a software repository, say read a software repository's contents in order to extract different kinds of information that go to the central software analytics database, which somehow, or in a sense, gathers all the information but in a condensed form. So this is how mining software repositories works. Typically they exist, and typically they are not interlinked, or at least not heavily interlinked. And the data and the metadata stored in these repositories is the most important input for visual software analytics, which is then analyzed, maybe by data mining algorithms, and then visualized by different concepts, for example, by software maps. Yeah, so now let's ask, what can we actually do with mining software repositories? What are possible objectives? One possible objective is to learn more about a software system, understanding software systems. The software repositories typically serve as a kind of group memory for software development projects, a group memory that holds all the activities and activities taken in the past. It helps to understand and comprehend complex computer-based systems, and this is often hindered by rare or out-of-date documentations or by frequently changing developer teams. So this group memory should not depend on individuals in a large and long-term software project. The relevant data is already there in software repositories. For example, mining software repositories can help to reveal details about the history of a specific artifact, maybe over a long period of time, or it can help to uncover rationales for the current state or design of a given artifact. Another objective is to predict and identify bugs. Software quality metrics, for example, software complexity metrics, can be used as predictors for buggy or risky source code. In software repository mining, there's a different approach. Best predictors of bugs are assumed to be prior bugs and prior changes. That is, code that has bugs in the past is likely to have bugs in the future, and bugs are not likely to appear in unchanged code. What you see here is that mining software repositories offers a completely complementary approach. You could, for example, identify and predict bugs based on software quality metrics. This is the traditional way, so to say. But there's also a complementary approach that simply says, well, let's look what happened in the past. Where did we have bugs? Because where we had a lot of bugs, the likelihood that there are still bugs is high compared to those parts that did not change. So mining software repositories is a very helpful and effective means for bug prediction and identification. In the same sense, mining software repositories can also be used to understand the propagation of changes by mining co-changes. That means if source code is changed in one module, that change most likely impacts other modules too. For example, due to changed assumptions and conditions for module use. Hence, a change has to be propagated to these modules to ensure the system's integrity and consistency. Or change propagation still relies to a significant degree on empirical knowledge of experienced developers and communication. Dependency graphs provide a formal mean to identify modules for change propagation, but they are typically incomplete. Yeah, with the approach of mining code changes, we have a different way to approach this underlying problem. In software repository mining, it is assumed that modules co-changing in the past are likely to co-change in the future. Based on this assumption, we can identify this kind of historical dependencies. So what you see here is that looking back in the past and analyzing changes and co-changes gives a kind of prediction about future co-changes that might be necessary. Once again, contrast to software quality metrics, this is an approach that is empirically based because it looks back, taking into account data stored in software repositories. Another objective, understanding team dynamics. Teams communicate through a number of systems such as email, mailing lists, instant messaging, blogs, etc. about different issues, including design questions, alternatives, decisions, project policies, bug reports, code reviews. The communication information can be mined as well to understand the dynamics of the software development team and to take advantage of it for future tasks. Example, mining the most qualified team member for handling a bug issue by mining prior bug reports and historic communication information. Yeah, the team dynamics represents also a completely independent universe of information. And this communication might be stored in email archives, for example. Yeah, what are the limitations? If we look at mining software repositories, there are some obvious limitations. Version control systems have not been designed with automated mining in mind. That means they are not explicitly shaped towards the mining of their contents. High complexity associated with extraction and analysis of data of software repositories. Yeah, it's still some extra work to do, for example, done by software analytics tools to get out to inquiry all the data stored. So it's not an intrinsic feature of software repositories that is mining, is still not a built-in functionality. No common or standardized format for repository records or operations. Also a big disadvantage. Extraction of high-quality data is faced by partially unstructured, non-formal information in software repositories, especially if you look at repositories such as email, archives, or bug descriptions. They are not formalized and they are not formally structured, typically. Linking across different types of repositories is rarely used, but is needed, and this is also done by visual software analytics. Quality of data stored in software repositories has to be improved and assured. So sometimes you have a certain amount of data that is less accurate, for example. So Repository data cannot be used to conclude causation. Instead, it can only show correlation. So this somehow summarizes the key limitations here. Yeah. Now, what about this part? Mining software repositories. Software repositories support different kinds of software maintenance tasks. This is obvious. They store and archive a wealth of information about software project over time. They can store not only software-related artifacts, apply changes and related metadata, but also data about runtime execution, test executions, bug handling, developer communication, and their activities. So we have different kinds of software repositories. Now, mining these repositories is an essential task in software analytics, as it reveals valuable information about evolution, dynamics, and management of large-scale, long-term software projects. In particular, it provides substantial information. Mining provides substantial information for system understanding and comprehension. It helps to identify potentially buggy or risky system components, assists in managing change propagation, and generally reveals insights into the team dynamics. Yeah, this concludes this part about mining software repositories. We have introduced key terminology. For example, software repository. A software repository represents a record-keeping database that stores data and metadata about artifacts of a complex computer-based system and changes applied to them. And mining software repositories denotes concepts, methods, techniques, and tools that examine and analyze data of software repositories to uncover pertinent information, relationships, and trends about a particular evolutionary characteristic of a system. As further reading, I can recommend this very general paper, The Road Ahead for Mining Software Repositories, which outlines with much details this very attractive and recent field in software engineering. Yeah, to end this part, some remarks. The wealth and benefits of information stored commonly in software repositories are obvious. We don't have to discuss the need for a software repository because most projects use different software repositories quite successfully, and yet for a long time. But a key limitation results from the fact that these software repository systems initially have not been designed to become parts of software analytics systems or to serve data-driven software engineering. So often they operate in isolation. That is, it is up to specialized tool solutions to close this kind of tool gap in the future. Mining software repositories provides valuable information to software analytics. So software analytics is a primary user of data and metadata stored in software repositories, especially because they allow us to obtain a developer-centric and evolution-centric or even history-centric perspective. Advanced mining techniques, such as for change propagation, automate and implement what would be otherwise only provided by the experience of individual developers. Consequently, mining complements software analytics by data-driven insights about project history and team dynamics.